Greetings, welcome back to Black Bear News, where we are discussing, covering, expounding on, contemplating. We're not actually trying to figure out whether this is actually happening, because we know it's happening, but we are discussing abrupt climate change, environmental degradation, environmental collapse, species collapse. How about that one? Many articles to cover as usual. It's been a couple days since I've been able to get here. There were just some days when it is wall-to-wall things, and no time at all. If I could actually function with less sleep, I totally would. Like, I wish I was one of those people that could that could actually do things and do them like well on 4 or 5 hours of sleep. But I'm just not one of those people. So like, I absolutely need every single minute and second of 8 hours of sleep to even feel halfway normal. That's just how I am. So I'll read some articles. Somebody left a funny comment about, do you even read your comments? What is this channel about? Obviously, generally when people leave negative commentary on this channel, they're not really paying attention. They're just, they're usually having like a reactionary fit or something. They're just coming on here to spew stuff, but it's totally fine if you actually pay attention, if you actually just hang out, read the comments, watch the videos, watch a few, interact with people in a kind and cooperative and positive way, and maybe maybe people can be enlightened, maybe knowledge can be exchanged. That is actually the point of this channel. Is for there to be an exchange of knowledge, not just necessarily a soapbox or a megaphone of what I think. That's not the point of this. But the actual point of this channel is to delineate, to define where we are in our geological era, epoch, whatever you want to call it, to figure out what is actually going on the earth, and possibly what might be done about it. What might be done to put us on a path towards, not total destruction. At this point, it's looking very grim. It's looking very dire indeed. Many people know this, but I will just say, if we're going to hold out hope, or if we're going to do the right thing, or if we're going to take right action, what is the action? What is that action? What are the things that people might be thinking about doing? I was just watching a video with Professor V. Ramanathan from Understanding Climate Change. Yes, it is. And good video. I will link it below if you all want to check this out. It's a long video. I watched most of it, haven't even finished it, but I'm watching it. And he has quite a few things to say, and he's talking about, possible ways forward. Again, he actually is very aware of how bad the situation is, and yet he is trying to come up with solutions, possible actions that we can take. Well, interestingly, one of the things that he said was that he's part of a group that discusses these problems, and at the top of their list, when they discuss what are all the factors that are involved in technology and our social political system or social, social awareness, like the top of the list is our social organization, basically, what it is, how it is that the human species runs itself or runs its society. I'm sorry, I didn't really know I was going to go down this little ranty road for so long, but I thought that was very interesting. Obviously, of all the, there's so many different, answers that people have, or, if we just lower the population, or if we just, did this, if we have a technological fix. Seriously, if there is a path out of this, it can't just be, it really can't be like a one, there's not a one thing that's going to fix this. And if you wiped away fossil fuels, if you took down the system immediately, obviously that would cause a lot of problems. So you can't wipe away the system. You can't have a system collapse or failure, because the system collapse or failure would wipe us out. So it would be a very, very tricky road to walk back into some kind of safety or plateau, to walk out of danger. It would be very difficult. You'd have to have a political reorganization while you were still continuing to kind of keep society going. You'd have to make very, very hard decisions about, who gets what, and who, what do we have money for, and, who gets to keep what. And, it's just, there's so many moving parts. It's such a complicated problem. However, if we had the brain power, and there are people putting their brain power to this problem, we possibly, maybe, in a one in whatever the odds are for us to avoid certain catastrophe, 1 in a million, 1 in 10 million, 1 in a billion. I don't know what the odds are. The odds are very, very large against us. But if we have a chance, we're going to have to do this in a very thoughtful way. The interesting thing, though, that I was thinking about today is that at the very core of there's a problem that humans have, in that they don't want to be told what to do. That freedom, we have kind of this double standard that we live in, that, we want to be free to do whatever, free to do whatever we want to do, and, unencumbered by, this is why, Trump is so popular with people, is, because we're going to take these regulations away, but at the same time, he's, but all these people are going to be, we need law enforcement to get rid of all these people, right? So there's this like double speak thing going on, but people are so like, oh, I must, we have to be free, and you can't constrain humans, and you can't tell them what to do, and you can't put limitations on them, and there's a big ass problem with that. There's a big ass problem with that thought, that we can do whatever we want, and we are living that out. We are living that humanist, whatever, that, speciesist idea that we can do whatever we want, and nobody tells us what to do, and nobody can constrain us, and without consequence, right? We think we can do that without consequences, and the consequences have not been met yet. Past cultures, past human cultures, have met the consequences of overshoot, and it wasn't very pretty. And here we are with all this technology at hand, and all of our, we don't even want nature to tell us what to do, right? We want to keep living longer. We don't want to get sick. We don't want to be subject to forces of nature, right? Hunger or disease, or we don't want to, we don't want to have any of this nasty stuff come at us. Basically, is what humans want is, we want everything, and we want ease, and we want comfort, and we want freedom. And so, that's the double bind that we're in, that we are, and it's also the double bind of being a humanist, being, somebody who, like, I am a humanist, I care about people, and I want people to live and be healthy, and be free from oppression, and free from, free from all the bad things that we want, we don't want to be subject to in life. And somewhere in there, we have to decide that we also, where does this road lead us? This road of being free to do whatever it is that we want to do, to live however long we want to live, to have as many children as we want to have, to, I don't know. Does just making things right and just for all humans on earth, and giving them a way to live, comfortably and simply, does that road just level out all the other problems? I don't know. This is a time when we need to have, some new social political philosophies, right? In the last century, we had, all these kind of major philosophies that had been developed over the last couple centuries, and they had all, people were like, let's try this, let's try communism. What about democratic socialism? What about, what about despotism? What about, we had all these kind of like new ideas about how to organize society, come and go. And now now we have global, I don't know what you want to call it, global fascism, basically, under the guise of, global economic, what would you call it? Prosperity? I don't know. It doesn't seem very prosperous for a lot of people. We could call it global economic inequality, for sure. These are just things I'm thinking about, questions that people could be asking, or questions that people might even have the answer for. I don't have the definitive answer, but, these are things that are all going to be part of the way forward. If there is to be a way forward, we are going to have to reorganize ourselves. We are going to have to rethink what it is to be human. We're going to have to rethink what it is, all that cultural programming has to go out the door. Like, everything that you think, it means to be, human and live in this world is, up for debate, really. And it has to be up for debate, because the way we're doing it isn't working, if that isn't obvious to you. I'll read some articles. So, obviously there seems to be, and there is, a lot of extreme weather events going on. And this does not bode well for this year, even though, like, strangely, right now in Southern California, we are very, we've been very mild. We've been very kind of even for the last month or two. And I fear that it is a lull before some not so nice stuff. But in lots of other places, there are many things going on. There's heat waves in the Midwest. I'm going to read this article about some brush fires in Australia. Albany brush fire, 2 blazes burn out of control in WA's Great Southern, threatening lives and homes. 2 brush fires are threatening lives and homes around Albany and other communities across Western Australia's south coast as winds from the season's first strong cold front fan flames, sparking spot fires up to 1.5 kilometers ahead of one blaze. One of those fires is burning 10 kilometers west of the city of Albany in the Redmond area, and the other is in the Napier area near the Porangurup National Park, about 20 kilometers to Albany's northeast. More than 30 fires remain active in the region, and DFES said it was an unprecedented fire situation within the city of Albany. At least 2 homes have been lost in the town, Wellstead, east of Albany. According to Albany Mayor Dennis Wellington, one house confirmed as being burnt out. There's another shed, which is full of farm materials, burnt out. All right. 2 fires threatened to combine. Department of Fire and Emergency Services Superintendent Wayne Green said one of the biggest concerns was the fire burning in Napier, about 30 kilometers northeast of the city of Albany, which is home to about 35,000 people. An emergency warning has been issued for the Napier fire, which is threatening to join up with another fire burning in the southeast of the Stirling Ranges, a rugged and mountainous national park north of the township. And apparently there's a storm a-brewing. What's this? The southern half of the state is also being battered by the first strong cold front of the season. But while strong winds are whipping up flames, there is not enough rainfall to have a major impact on most of the fires. Okay, that's all I'm going to read of that article. I'm going to link it below. And I'm going to move on to another weather situation. This is from Robert Scribbler, who's becoming a regular, someone I read from regularly. Thank you guys for continuing to send me articles and links and put links in the comments. Many of these articles I read on this channel are from you all, so thank you. Odd and dangerous Mekunu bears down on Oman. And this is, I think this is just from a day or two ago. This year, 2 tropical cyclones have sprung up in the Western Arabian Sea, a region where, according to our understanding of climate, storms do not form, quote unquote. Well, the climate has clearly changed, because the storm is raging there now, and for Oman today, these changes bring with them serious threats to life and property. And there's a video in here to watch, which I am going to watch myself. About 5 days ago, tropical storm Sagar formed east of Somalia in the Western Arabian Sea near the Gulf of Yemen. The storm was notable due to the fact that it was the furthest west a storm had ever formed in the region, according to records. The storm then dumped copious amounts of rainfall over Somalia, resulting in the loss of 34 lives. Just a few days later, a second storm, Mekunu, formed in about the same region. Tracking north, it is now threatening Oman, with the potential to hit Category 2 intensity. Unlike Sagar, Mekunu poses a triple threat due to expected very heavy rainfall, large waves, and storm surge. Mekunu ranges south of Oman and Yemen after forming in the Western Arabian Sea. The region near Salalah, Oman, that the storm is barreling toward, typically receives just 5 inches of rainfall per year, but Mekunu could deliver 2 to 5 times that amount or more in just a few days. Moreover, the flat coastal plain is backed by mountainous terrain to the north. The higher land produces lift that will intensify expected rainfall, and current models predict that more than 2 feet of water, 24 inches, could fall on upsloping regions facing Mekunu's advance. What's notable is that these totals keep rising, and that peak local totals for the storm and the NOAA NCEP model show some ridiculous amounts, up to 74 inches. Why are peaks in this model so high? First, sea surface temperatures are very extreme throughout the region. In the immediate vicinity of Mekunu, Ocean surfaces range from 30 to 32 degrees Celsius. The waters are about 1 to C above normal and 1 to 2 C above normal, and are thus providing Mekunu with a lot more moisture than is typical. Moreover, or however, the larger environment that Mekunu is feeding off also has much higher than typical moisture loads. For one, sea surfaces east of Somalia have spiked to as much as 5 C above average recently, pumping out great loads of evaporation. Further, moisture levels above the Arabian Peninsula are high due to moisture streaming in along a rather intense subtropical jet stream moving over the also much warmer than normal sea surfaces in the Mediterranean. The result is a much higher than normal rainfall potential. Such heavy rains would flush floods of water into lowlands already confronted with high waves and rising seas. According to a recent report by Bob Henson at the Weather Underground, wave heights could reach 24 feet along the coast. The same report cites storm surge expert Dr. Hal Needham, who states, "The significant wave height leads me to think coastal flooding flood potential is a real threat. At some point, the water from waves crashing on shore does not have time to drain before the next wave hits. My gut feeling is that we would see a noticeable storm surge that is quite dynamic, with a lot of wave action and rapidly moving water. Expect wave heights to be tremendous." Much warmer than normal sea surface temperatures in the Mediterranean and Arabian seas are helping cyclones to form in atypical regions, even as they are lending fuel to their intensification. Mekunu's intensity is certainly quite high, and it is one of a recent spate of storms to impact the region, with research showing that the intensity of storms in the Arabian Sea has increased during the last 20-year period. However, the far western formation of Mekunu and Sagar add a new twist to the story, for it appears that the zone of storm formation is also shifting westward as sea surface temperatures rise, and apparently jet stream changes have the potential to deliver higher levels of atmospheric moisture to the Arabian Peninsula. All of these factors feed both storm formation and intensity potentials. So we have storms forming where they do not form. They're not supposed to form. We had a storm we had a cyclone formation in the southern Pacific off the Chilean coast, which never happens. So what does this all mean? I wonder. So that was from a few days ago, and in more recent news, Cyclone Mekunu looking like it has killed some people. Let me just see. This is from an hour ago. Mekunu strikes Oman. Can I get the headline, please? 2 Indians among 7 dead, more than 30 missing. So they are experiencing that right now. Three people, including a 12-year-old girl, died in Oman, and another 2 bodies were recovered from a Yemeni island of Socotra. More than 30 people are still missing in Socotra, including Yemeni, Indian, and Sudanese nationals. Let the extreme weather games begin. I'm going to link all these articles below and move on to, I'm going to link a very short clip. It's literally 2 minutes from Jennifer Francis, who I've linked some videos of hers before. She's very, very, very good researcher of climate change. She has lots of videos on the YouTube if you would like to go check her out. But anyway, she just is describing a new catastrophic new Arctic feedback. Basically, the wavier jet stream being responsible and enabling warm air to go up to the Arctic and push out the cold air. So you guys that are like, it's been cold this winter, the reason why it's been so cold and why the storms were so severe is because warm air that's not supposed to be in the Arctic is pushing out the cold air that's supposed to be in the Arctic down south. And I also believe there was, like, you know, a number of storms in Europe and Russia that were, you know, pretty crazy as a result of this, you know, polar vortex phenomenon or whatever you want to call it. But it's basically a symptom of climate change. As the warm air goes into the Arctic where it's not supposed to be, it pushes the cold air out onto us where it's not supposed to be, making for extreme weather whiplashes. Moving on. The Arctic had a scarily low amount of ice this past winter. 5 reasons the Arctic's extremely warm winter should alarm you. It's from March 23rd. Cape Morris, Jesup in Greenland is just about the northernmost piece of land on planet Earth. It's located just 400 miles south of the North Pole on Greenland's craggy, desolate North Shore. This is a place so far north that the sun doesn't rise for most of the winter months. In February, in the dark of winter, Cape Morris, Jesup's weather station recorded nearly 60 hours of temperatures above freezing. This is February. Think about that. A new record. On February 24th, the temperature reached a high of 43 degrees Fahrenheit. This is February 24th. It is not getting colder. Dear solar minimum people. Think of it like this. On February 24th, you could be standing on the northernmost bit of land in the entire world in the darkness in shorts and a t-shirt. That you wouldn't quickly die is astounding because the Cape's temperatures are usually closer to minus 30 degrees in February. It's often said that on this warming planet, nowhere is changing faster than the Arctic, but this winter is providing stunning new evidence of a region in extraordinary, worrying flux. On Friday, we got another bit of evidence this is true. The National Snow and Ice Data Center announced that this winter's Arctic ice maximum was among the smallest in history. During the winter months, the polar ice cap grows and grows. It's a very strangely worded sentence because it said grow and grows. But this year, its final size covered an area of 448,000 square miles, less than the 1981-2010 average. The 4 lowest seasonal maxima have all occurred during the last 4 years, the NSIDC reports. That's a truly troubling trend. Less ice in the Arctic triggers a feedback loop. The less ice, the more solar radiation is absorbed into the ocean, and that makes the region even warmer and leads to even smaller amounts of ice. It's also a hint of the future to come, an Arctic Ocean that's not permanently frozen and all the disastrous consequences that will come with that. Number 1, it was the warmest Arctic winter on record. Overall, this winter, as measured by December, January, and February, the 3 coldest months, was the warmest on record. As the Associated Press reported, Arctic weather stations averaged 8.8 degrees Fahrenheit above normal. These Arctic warm spells do occur due to natural variability, Alec Petty, a NASA polar scientist, says. But the key is that they are happening more frequently, they are lasting longer, and they have been more intense than they used to be, he says. Indeed, this is the 3rd Arctic winter in a row that experienced an extreme heat wave. 2, there's new evidence that weird weather in the Arctic impacts our weather. Early in March, Nature Communications published a study looking at temperatures in the Arctic and in North America from 1950 to 2016, and it found a correlation. When the Arctic is weirdly warm, it tends to be weirdly cold and snowy down here in the continental United States, particularly the East Coast. We saw this pattern on display this year. If you can think back to New Year's Eve, it was well below 0 degrees Fahrenheit in some places on the U.S. East Coast. Meanwhile, it was around 30 degrees in Alaska. That's not normal. Climate scientists still don't know what causes this pattern or whether it's becoming more common due to climate change. One unproven hypothesis is that a warming Arctic decreases the strength of the jet stream, which is what Jennifer Francis is talking about. This air current acts like a tourniquet, keeping Arctic air from bleeding out over North America. It's also hard to say what the direction of the correlation is. Is the Arctic weather impacting the weather down south, or other way around, or a little bit of both? The researchers in the Nature Communications paper suspect it's the Arctic that's driving the trend, but it's not conclusive. Whatever the cause, know this: weather is global, and when the Arctic becomes weirdly warm, the consequences can hit close to home. Number 3, there were record low amounts of ice, continuing a decades-long downward trend. There's no land at the North Pole. It's a frozen ocean. One of the most spectacular yearly cycles on Earth is the freezing and thawing of huge swaths of this ocean. Throughout the winter months, the ice cap doubles in size from nearly 3 million square miles to nearly 6 million. Here's NASA's illustration of what the sea ice extent looked like in 2015 through the early months of 2016. It's a beautiful reminder of how the seasons transform the land and life on it. Every year, polar scientists measure the extent of the sea ice during the winter. That is, how much area in the Arctic Ocean gets frozen over. And every year, on average, that area gets smaller and smaller. The record low was last year. The second lowest was this year. 2016 and 2015 are virtually tied for third. This trend shows no sign of reversing. In the following chart of sea ice extents, you can clearly see how the average maximum winter sea ice declines every decade. The record low levels of ice also led to another Arctic first. For the first time ever, a ship was able to navigate the Arctic Ocean north of Russia during wintertime. This milestone is partly due to technical advances in shipbuilding, but is also due to the fact that there was less ice in the waters this year, and that the ice that remained was thin enough for the ship to break through. In the most recent Arctic Report Card, an annual assessment of the Arctic environment, NOAA concluded that the region shows no sign of returning to the reliably frozen region of recent past decades. This winter showed this trend is not letting up anytime soon. The loss of winter sea ice, Petty says, reinforces the message that we're radically changing the climate system. Number 4, scientists saw unsettling signs that the remaining ice is getting thinner and less stable. A big conclusion from NOAA's last Arctic Report Card was not only is the Arctic's ice sheet shrinking, but what ice remains is growing less stable. In 1985, 45% of the ice in the Arctic was more than a year old. In 2017, that figure was down to 21%. Younger ice is thinner than older ice and more susceptible to changes in temperature and to melting. Thinning ice makes life tougher for polar bears, which travel on ice sheets to find food. And this winter, polar scientists saw something unheard of happening to some of the oldest, thickest ice left. In late February, satellite images showed a hole in the ice, i.e. exposed water, just north of Greenland. That's where scientists expect the ice to be at its thickest and most stable, Petty says. Yet this winter, winds were able to push it offshore. Scientists don't expect this area to be ice-free in the summer. And they're currently unsure if such a hole has ever been observed before during the winter. Melting sea ice does not contribute much to sea level rise. Watch an ice cube melt in a glass of water. The water level won't rise because the ice is less dense than water. And when it melts, it just fills in the exact area displaced while solid. This is basically true for what happens when the polar ice cap melts, but because fresh water is less dense than salt water, when the fresh water in the Arctic ice melts, it does not raise the sea level by a tiny bit. It does raise the sea level by a tiny bit. More importantly, the melting ice does impact something that contributes greatly to sea level rise, land rise. As the sea surface melts, it grows darker, which traps more heat, causing more melting. That leads to warming in the whole region, and that's critical because sitting on top of Greenland is an enormous ice sheet. If this land ice melts into the water, it will cause a global sea level rise. If all of it melts, scientists estimate the sea level will be 25 feet higher, and as polar scientists observe declines in Arctic sea ice, they're witnessing a concurrent acceleration of melting in some parts of Greenland, as Vox has reported. Number 5, an ice-free Arctic could come within decades. Arctic sea ice extent has been measured by satellites since the 1970s. So while climate scientists suspect we're witnessing the greatest decline in Arctic sea ice in human history, it's hard to prove conclusively. Yet scientists can make some guesses about historical ice extent by sampling ice cores, permafrost records, and tree rings. In the latest Arctic Report Card, NOAA included this chart. which plots the estimated sea ice area for the past 1,500 years, and, well, it looks a little scary. It looks scary because it's basically dropping straight down to zero. In a few decades, polar scientists predict that the Arctic will become virtually ice-free with less than 1 million square kilometers of ice, a bit larger than the size of Texas, during the peak of summer. This has a lot of geopolitical consequences. As Vox's Johnny Harris explained in a documentary, Russia is now positioning itself to be the dominant country when it comes to shipping routes in the Arctic Ocean. This winter was extreme, and it only suggests that this ice-free Arctic may arrive sooner than later. If you project forward in time using climate models, that's suggesting timelines of 20 or 30 years for an ice-free Arctic, Petty says. But these strong changes we're seeing in winter might mean this could happen a lot earlier than those projections suggest. There are other entities, scientific entities, that suggest that have predicted an ice-free Arctic this year, give or take, plus or minus 2 or 3 years. So there are some people that think it can happen by 2020. Not 20 or 30 years, 2 or 3 years. Last article I am going to read. Not too long. This is called Great Acceleration. I don't know if I see a date on this. 2007. Anyways, this has some like pretty cool little graphs, images in here, and you can see kind of just gives you, well, a look at how everything is accelerating due to humans on the planet. The second half of the 20th century is unique in the history of human existence. Many human activities reached takeoff points sometime in the 20th century and sharply accelerated toward the end of the century. The last 60 years have without doubt seen the most profound transformation of the human relationship with the natural world in the history of humankind. The effects of the accelerating human changes are now clearly discernible at the Earth system level. Many key indicators of the functioning of the Earth system are now showing responses that are, at least in part, driven by the changing human imprint on the planet. The human imprint influences all components of the global environment: oceans, coastal zone, atmosphere, and land. Dramatic though these human-driven impacts appear to be, their rates and magnitudes must be compared to the natural patterns of variability in the Earth system to begin to understand their significance. The increase in atmospheric carbon dioxide concentration provides a useful measure with which to evaluate the rate and magnitude of the human-driven change compared to natural variability. The human imprint on carbon dioxide is unmistakable. In December 2014, our atmospheric carbon dioxide concentration stood at 399 parts per million. So this article is clearly after 2014. Stood at 399 parts per million by volume, over 100 parts per million by volume above the previous maximum level of around 280 ppm recorded in the Vostok ice core. Within the current limits of resolution of the ice core records, the present concentration has been reached at a rate at least 10 or possibly 100 times faster than carbon dioxide increases at any other time during the previous 420,000 years. 100 times. Thus, in this case, human-driven changes are well outside the range of natural variability exhibited by the Earth system for the last 500,000 years, at least. Over just the past few hundred years, human activities have clearly evolved from an insignificant in terms of Earth system functioning to the creation of global scale impacts that are approaching or exceeding in magnitude some of the great forces of nature, operate on much faster timescales than rates of natural variability, often by an order of magnitude or more. Taken together in terms of extent, magnitude, rate, and simultaneity, have produced a no analog state in the dynamics and functioning of the Earth system. Simultaneity. The domino effect. Human impacts on the Earth system do not operate in separate, simple cause-effect responses. A single type of human-driven change triggers a large number of responses in the Earth system, which themselves cascade through the system, often merging with patterns of natural variability. The responses seldom follow linear chains, but more often interact with each other, sometimes damping the effect of the original human forcing and at other times amplifying them. Responses become feedbacks, which in turn can lead to further forcings that can alter the functioning of the Earth system. The nature of the Earth's system's responses to the increasing anthropogenic forcing is more complex than simple cause-effect relationships, such as greenhouse gas emissions causing global warming. Fossil fuel combustion produces a range of gases that have a large number of cascading effects. For example, carbon dioxide not only affects climate, but directly affects how vegetation grows. It changes the carbonate chemistry in the ocean. The oceans are becoming more acidic, which in turn affects marine organisms. Changing carbonate chemistry is a factor in the widespread decline of coral reefs around the world. Fossil fuel combustion also produces oxidizing gases such as nitric oxide and sulfur dioxide that have well-known effects such as acidification and eutrophication of ecosystems. However, these gases can eventually contribute to changes in fundamental Earth system functioning because of their indirect effects on the radiative properties of the atmosphere and hence climate. The mechanisms are through reactions with other gases plus their impacts on the ability of the atmosphere to cleanse itself through oxidization and other processes. Aerosols produced by fossil fuel combustion can fertilize or reduce plant growth depending on the circumstances and directly affect human health. They also lead to large-scale direct or indirect modifications of the climate. We can trace even more subtle effects back to fossil fuel combustion. Increasing carbon dioxide levels affect the stomatal opening of the terrestrial vegetation, reducing water vapor loss through the stomates. This results in higher water use efficiency. This effect is especially pronounced in semi-arid vegetation and can lead to increased productivity through enhanced soil moisture. More generally, no two species reacted in an identical way to elevated atmospheric carbon dioxide concentration. This leads to changes in competitive abilities of plants and hence to changes in species abundances and community composition. Fossil fuel combustion cascades through the Earth system to become even a biodiversity issue. Like fossil fuel combustion, land cover and land use change also trigger widespread cascading effects at local, regional, and global scales. We can show a few ways local effects of land use change cascade through regional to global scales. Multiple interacting stresses. Global change does not operate in isolation, but rather interacts with an almost bewildering array of natural variability modes and also with other human-driven effects at many scales. Especially important are those cases where interacting stresses cause a threshold to be crossed and a rapid change in state or functioning to occur. Scary stuff there, and if you look at the graphs, they're also very scary stuff. Good to know where we all are at, so that we can know where to go, how to go, or know when it goes. Even. Thank you so much for your eyes, your ears, and your conscience. I appreciate all of your interacting on this channel and your comments. Always. If you would like to support this channel, you can do so with the links below. I hope to be back tomorrow with another video. Until next time, peace.